Good morning, CC3 students, and welcome back. Yesterday's video, we talked about finding slope. If you have not done that video yet or that worksheet practice, I suggest you stop right now, go back and do that first, because today's video, we are going to be looking into an IXL code that has us comparing different linear functions. And in order to compare, you have to be able to calculate the slope of each linear function. We're going to be looking at comparing functions of given graphs of the line, given a table with points, or given the actual equation of the line. So again, it is very important that you have done yesterday's video before attempting today's. So without further ado, let's go ahead and get started. We're going to be looking at our IXL code for today. And you, for now, can either open up an IXL a window to kind of follow along, or just grab a piece of paper and you can kind of just practice with some examples and stuff like that. So here we go. Okay, so once you log in, your IXL code today is going to be N7D. N, the number 7, and D. It's called Compare Linear Functions, Tables, Graphs, and Equations. So when you click on that, and then it's also going to be in your recommended skills, because I'm going to go ahead and recommend that for you as soon as this opens. There we go. So we're going to recommend that for both of you guys. Okay, so we are comparing, okay? That is the key word here. We're going to be comparing functions. So you're going to be given two functions in each of these, and most of these are multiple choice questions, okay? So it's either going to be one or the other. So function A and function B are linear functions. Notice that function A, they give us the table of the function, and function B, they give us the equation. So these are two completely separate, different linear functions, okay? Which statement is true? The slope of function A is greater than the slope of function B, or the slope of function A is less than the slope of function B. So notice we are comparing slopes here. So really what we need to do is we need to find the slope in order to compare the slope. So let's start with function A. Function A, now remember, slope is change in y over change in x. So function A, how do you calculate the slope in a table? Well, to calculate the slope in a table, you start by just finding the rate of change. So how do I get from -16 to 0? That's a change of +16. And how do I get from -7 to 1? Let's see, -7 plus 7 is 0, plus 1 is +8. So my first change here, it shows that my rate of change is 16 over 8, which can be simplified to, what is that, 2 over 1. Let's see if that's also the same when we calculate the next change. The next change is from 0 to 6 is +6, and from 1 to 4 is +3. So that's a change of +6 over +3, which also simplifies to 2 over 1. So the slope of function A is 2 over 1, or we could just call that 2, okay? Now function B should be a little bit easier because we're actually given the linear function and it is in slope-intercept form. So remember, when you're given a function in slope-intercept form, the slope is just the multiplier of x. Now, I hope you're looking at that going, wait a minute, there is no multiplier of x, there's nothing there. So the common mistake here is to think that this is 0. But if it was 0, x wouldn't be there either. So what is always hidden in front of every number? Like, what times x also equals x? That is a hidden 1. So this could be the same thing as y equals 1x minus 4. So in this case, the slope of function B is 1. So the slope of function A is 2 and the slope of function B is 1. So which of these is true? Is A greater than B, or is B A less than B? Well, 2 is greater than 1, so we know our answer must be the first one here. The slope of function A is 2, the slope of function B is 1, so the slope of function A is greater than the slope of function B. Let's see if that's correct. And it is, awesome. Okay, now here we go. We have our second question here. We're given two functions again, and it's asking us the same question. Is the slope of function A greater than the slope of function B, or is it less than function B? But this time we're given a table and we're comparing it to a graph. Isn't that exciting? We get to do two different types. Okay, so let's start by calculating the slope of function A, which again, remember, slope is just change in y over change in x. So if you're following along, what I would do is I would just copy this table down on a piece of paper so that I can actually do this work. All right, let's start with change in y. How do I get from -19 to -3? How far away are these two? Well, my negative's becoming a little bit smaller, so I know I'm adding. Then how far away are 19 and 3? I think they're 16 away. Yeah, I believe that. So here my change in y is +16. How do I get from -7 to +1? Let's see, -7 plus 7 is 0, plus 1 is 8. Do I believe that? Yes, I do. So this is a change of +8. So in this case, my change in y was +16 and my change in x was +8, which simplified is 2 over 1, or just 2. Now, to make sure that we did that right, it's always a good idea to calculate the second change to make sure it's the same as the first change, because if it's not, then you made a mistake with your math. How do I get from -3 to 11? That's a little tough. I'm going to draw a number line here. If I start at -3 and I have to end at 11, 0 is going to be in between there. So how do you get from -3 to 0? I would have to add 3. And then how do you get from 0 to 11? I would have to add 11. So what's 3 and 11 combined? That's a total change of +14. That's how I like to figure that out. So my second rate of change was +14 plus 14. And then this one's a little easier. How do you get from 1 to 8? You would add 7. So let's see. My second rate of change was I had +14 over +7, which 14 over 7 is still 2 over 1, or 2. So the slope of function A is 2. Wasn't the slope of function A 2 last time also? I think it was. Okay, so the slope of function A is 2, so that means the slope of function B has to be either greater than or less than 2. Now here's the tough part with a line. You need 2 points on a line to be able to calculate slope. So like I see a point right here, and then like maybe I see a point right there. And there's a bunch of points. You want to make sure that you're picking a point that's on an exact coordinate. So it looks like this is the point 0, 0, and this is the point 4, 4. So I'm going to calculate the slope here, change in y over change in x. And remember, we always go from left to right, or I always go from left to right. So I'm going to start at this point. This will be point 1, and this will be point 2. So how do I get from point 1 to point 2? Well, from here to here, point 1 to 2, I first have to travel up. I'm traveling up 1, 2, 3, 4. So my change in y is +4 because my y value increased by 4. And then I'm going to the right, 1, 2, 3, 4. So my change in x is also +4. So here's my rate of change. I moved up 4 and right 4. What is that simplified? Well, 4 over 4 is just a big 1. So the slope of function B is 1. Wasn't the slope of function B 1 on the last example? I can't even remember. Okay, so let's look at this. So the slope of function A is 2, slope of function B is 1. Which one is true? Is A greater than B, or is A less than B? Is 2 greater than 1, or is 2 less than 1? 2 is greater than 1, so that means this is our final answer. The slope of function A is greater than the slope of function B. And awesome sauce. All right, we are back to another table with a table and a function, table and a function. Now this is a little bit of a tougher question because this is not asking us about, what's it called? This is not asking us about the slope, this is asking us about the Y-intercept. So remember, Y-intercept is always in the form of 0, y, okay? It's always in the form of 0, y. So basically x is always 0. The Y-intercept is sometimes hard to find in a table, but it's not impossible. It's usually pretty easy to find in an equation. So let's actually find the Y-intercept of function B before we try to find the Y-intercept of function A. So Y-intercept, you basically are plugging in 0 for X, and then that will give you your Y. So when I plug in 0 here, this entire term becomes 0, and I'm left with Y equals -3. So the Y-intercept of function B is 0, -3. Or in other words, I think for the sake of this, they're really looking at it as -3. So either A is going to be greater than B or A is going to be less than B. Now in a table, we have never done this before. So this can be a little bit tough, but you're gonna actually start with finding the rate of change. So consider it this way, because I'm not given the Y-intercept. I'm not given what X is or what Y is when X is 0. So we're gonna start by just finding the rate of change. So what's the change from -16 to 8? That's a change of +8. And what's the rate of change from -8 to 4? -4, that's a change of +4. So +8 over +4 is just a change of 2 over 1. It's another rate of change of 2. That's crazy. We've done so many of those. All right, let's double check that. The rate of change from -8 to 2 is +10. And from -4 to 1 is +5. Let's just make sure that we believe all that. +10 over +5 is 2 over 1. Okay, cool. So that means my change in Y is I'm adding 2 every time I add 1 on the X. So notice how we're missing some points. Like we're definitely missing some X's between -4 and 1 and between, you know, all of this. So what I'm gonna do here is I'm actually going to rewrite this table. I'm gonna write it a little bit differently. I'm gonna write it like this, X and Y. I'm gonna write it horizontally, okay? And we're gonna use this rate of change to find the Y-intercept. Now remember, the Y-intercept, it always has an X value of 0. So I'm just gonna start from -4. -4 and -8, right? That's this point right here. What comes after -4? -3, then -2, -1, 0, and 1, 2 is our other point. Now this right here, this is going to be your Y-intercept, okay? So we're just gonna use the rate of change. I'm adding 2 every time I add 1 to the X. So every time I add 1 to the X, I'm adding 2 to the Y. So what's -8 plus 2? That's -6. If I add 1 to the X, add 2 to the Y, -6 plus 2 is -4. I add 1 to the X, add 2 to the Y, -4 plus 2 is -2. Add 1 to the X, add 2 to the Y, -2 plus 2 is 0. So my Y-intercept in function A is 0, 0. Or my Y-intercept here is 0. That was a tough one. Hopefully we get to do another one like this. So all I did was I just used the rate of change, which was positive, a change of +2 for the Y every time you move 1 to the X. And I just filled in the missing points in the table to find that the Y-intercept here is 0. Okay, so now we can answer the question, which is greater? Is 0 greater than -3 or is 0 less than -3? Well, negative is negative, so 0 is greater than -3. So that means the Y-intercept of function A is greater than the Y-intercept of function B. I'm gonna clear my work. Let's see if that was correct. And we were, look at that. Okay, now we're back to another slope question. So let's take a look at this one. I'm gonna take you all, I'm gonna do 2 more examples here and then we'll look at it a little bit more. A little bit tougher example. So the slope of, is the slope of function A greater than B or less than B? So let's take a look. So we start by finding the rate of change. What's the change from -8 to 7? We might have to do a number line for that. If I'm starting at -8 and I'm ending at 7, let's see, 0 is in between them. So to get from -8 to 0, I would have to add 8. And from 0 to 7, I have to add 7. 8 and 7 together means +15. So my first rate of change here is +15. How do I get from -4 to 1? That would be +5, because -4 plus 4 is 0 plus 1 is 5. So my first rate of change in the table is +15 over +5, which simplifies to 3 over 1. Just double checking that. We want to make sure that our math is correct. Let's make sure that it's also the same rate of change in the next 2 points. So how do I get from 7 to 22? 7, I think that's also positive 15. And how do I get from 1 to 6? That's also positive 5. So look, we still have positive 15 over positive 5, which means our slope of function A is 3 over 1 or just 3. Okay, let's look here. Now again, to find slope on a graph, you need 2 points. So I always like to choose the y-intercept as one of my points. And then I'm just kind of like, okay, how about that as my other point, right? You want to make sure you choose 2 exact points. Change in y over change in x. So I'm going to call this point 1. This is point 2. How do I get from point 1 to point 2? I first have to travel up 1, 2. So that's a positive change of 2. So my change in y is positive 2. And then I'm traveling right 1, 2. So my change in x is positive 2. 2 over 2 is a slope of, wow, look at that, another slope of 1. All right, so the slope of function A is 3. The slope of function B is 1. Which one is greater? I believe the function A has a greater slope. I'm going to clear my drawings here and see if that's correct. And we were, look at that. Awesome. All right, we got another y-intercept question, which I love y-intercept questions. Like love, love, love them. So let's take a look here at the y-intercepts. We're going to start with function A. So it's asking if the y-intercept is greater than in function A or function B. So remember, to find the y-intercept in a table, you first have to start with the rate of change. So how do I get from 9 to 13? That's a change of positive 4. How do I get from 1 to 2? That's a change of positive 1. So in this case, my rate change in y over change in x is positive 4 for every positive 1. And how do I get from 13 to 17? That's also a change of positive 4. And how do I get from 2 to 3? That's also a change of positive 1. So here's my rate of change. Every time y increases by 1, x increases by, or excuse me, every time y increases by 4, x increases by 1. So I like to look at things horizontally. I'm not a vertical thinker really, so I'm gonna draw this out horizontally. That looks really bad. I'm gonna try that again. Let's see. Okay. I mean, you could also do it vertically, but I like to do it horizontally. Now, if you look at this, remember the y-intercept, all y-intercepts have something in common. It's always 0, comma, and then whatever y is. So in all of these, x always equals 0. That's what's in common with the y-intercept. That looks weird. So what I need to do is I need to find the rate of change, or use the rate of change to find the value of x when y is 0. Now notice, I have points 1, 2, and 3. Well, I don't need to figure out 4, 5, and 6. I don't care when x is 4, 5, or 6. I care when x is 0. So I'm going to actually put 1, 2, and 3 here, and then 9, 13, and 17 here. So again, my change in x is that I'm adding 1 each time, and my change in y is that I'm adding 4 each time. So do I want to find this point here when x is 4, or do I want to find when x is 0? I want to find when x is 0 because this point will be my y-intercept, and that's what I care about. So really, you're going to work backwards. What's the change from 0 to 1? That's a change of positive 1. And then I want to make this change also positive 4. So what plus 4 is 9? That would be like doing 9 minus 4, which is 5. So in function A, my y-intercept is 0, 5, or for the sake of this, IXL, we're just going to look at it as 5. Okay, in a graph, the y-intercept is way easier to find. You're just going to find the points on the line that crosses the y-axis. So if I start from the left and I just trace up, boom, stop when you hit the y-axis. This is the point 0, 1. Or for the sake of this, our y-intercept is 1. Okay, so here we go. Which one's true? Is the y-intercept of function A greater than B, or is it less than B? Is 5 greater than 1, or is 5 less than 1? 5 is greater than 1, so we know this must be the correct answer. I'm going to clear my drawings here and submit, and there we are. Look at that. We're already in a SMART score of 47. I'm going to go ahead and jump a level here because this is, again, asking you for slope, and I feel like we've done that. So now we're going to jump all the way up to 60. This is where things get a little bit weird, but I want you to understand that it's the same idea that we've always been doing. You're dealing with linear functions, and you know how to do this. So here we're given function A and function B. We're given a table, and we're given an equation. Now it's saying the y value of function A when x is -1 is greater than the y value function B when x is -1. So this is very similar to when we're finding the y-intercept. The only difference is now we're trying to find the point in both of these where x is -1. We don't care anymore about when x is 0. We want to find when x is -1. So in a table, we're going to do the same thing that we did with the y-intercept. We're going to start with the rate of change, and then we're going to fill in our missing values in the table to find the value when x is -1. And then you actually already know how to do it with function B. It's just going to be plugging in. So let's start with function A. Tables are always a little bit tougher. So we're going to start with the rate of change. What's the change from -1 to 11? That's a change of +12. And from 1 to 5 is a change of +4. So our change in y over our change in x is +12 over +4, which is a change of +3 over +1. Now, we're not worried about slope, so I'm not simplifying this. I'm leaving this as a rate of change. Let's double check it with the other 2 points just to be sure that we're right. What's the change from 11 to 14? That's +3. And from 5 to 6 is +1. That's +3 over +1, which is already simplified. So the rate of change is +3 over +1. Why do we need that? Well, because we're trying to find the value of y when x is -1. So we're going to have to work backwards in this table to find it. Now, I like to do it horizontally, but for those of, yeah, I like to do it horizontally, so I'm going to keep it horizontally. So I'm going to write it out using this way just because I think horizontally more than I think vertically. Now, we want when x is -1. That is our goal. So I'm going to put -1 as my first value. And then since my x value is increasing by 1 each time, I'm just going to fill this in. -1, 0, 1, 2, 3, 4, 5. Okay? Now, when x is 1, y is -1. So we have 1, -1. And then when x is 5, y is 11. So these are the points that we know. We also know that the rate of change is +3 over +1. So that means every time x increases by 1, y increases by 3. So -1 plus 3 is 2, plus 3 is 5, plus 3 is 8, plus 3 is 11, right? We're just filling in the table. And these are all increasing by 1 each time. But what we really care about is this point right here. We want the, oh, I don't know why I did that. We want this one. We want to know what y is when x is -1. So let's work backwards in the table. Basically, the opposite of adding would be subtracting. So to go this way, I would be subtracting 1 each time. So we're going to be doing the same thing here. We're going to subtract 3. What's -1 minus 3? That would be -4. Again, the change from -4 to -1 is +3, so it matches. And then do it again. -4 minus 3 is -7. So the y value of function A when x is -1 is -7. We have -1, -7. But for the sake of this, we're only really concerned with this part right here, -7. Okay, for function B, when you are given a function, an actual equation, all you're going to do is you're going to plug in -1 for x. Just plug it in, and then you'll get your y. So really what we have here is y equals 3, plug in -1, minus 5. And then we're just going to simplify. 3 times -1 is -3 minus 5. So y equals -8. So the point here would be when x is -1, y is -8. But for the sake of this assignment, we're really just concerned with this piece right here, -8. So here we go. The y value when x is -1 in function A was -7. and if function b was -8. So which one's true? Is -7 greater than -8? Or is -7 less than -8? Now careful, your brain see 8 and think 8 is more than 7, but it's asking which is greater, meaning which one is closer to positive infinity, which one's more positive. In this case, -7 is greater than -8. So our answer here is this first one. I'm going to go ahead and clear my drawings and submit. And there we have it. All right, this is another one that asks about slope. So I'm going to go ahead and skip this one because I feel like the slope is a little bit easier to do. And this also has to deal with slope. So I'm going to skip this one. Let's see if we can find another tougher one. Look at this. Oh, okay, this is a good one because it has to do with a fraction. So we'll go ahead and do this one. Again, asking about slope and finding the slope of each one. So function A is a function in slope-intercept form. So here the slope is 5 halves. Okay, 5 halves. We're going up 5 and right 2. Over here, function B, let's go ahead and calculate the rate of change. What's the change from -11 to -2? I'm adding 9, I believe, because they're 9 away from each other. And from -8 to 4, ooh, that's a tough one. Let's see, -8. I want a number line, and I have to get to 4, zeros in between. That would be, that's a 0. +8, adding 8 there, and then adding 4 for a grand total of 9, or excuse me, 12. So for function B, my change in Y over my change in X, that looks a little funky, is +9 over +12. I think that can be simplified by 3. So 9 is 3 times 3. 12 is 3 times 4. These 3's are eliminated, and you have +3 over +4, or just 3/4. Okay, let's double check that here. -2 to -1 is a change of +3. 4 to 8 is a change of +4, which is +3 over +4, which is still 3/4. So the slope of B is 3/4. The slope of A is 5 halves. Which one is greater? Ooh, that's kind of a tough one with fractions. It's like, how do you know which one's greater? Let's think about that. On a number line, I'm going to go ahead and erase this. Erase all of this stuff because we don't need it anymore. Think about on a number line, if you had 5 halves, that like 5 halves inches or something like that, right? That would mean that if I'm starting at 0, oops, that could have been better. Let's undo that. I think I can draw a line here and then it'll be a lot nicer. Yeah, here we go. That looks way better. Okay, if I start at 0, okay, so here's 0, and each time I'm jumping a half, then this would be 1 half, 1 half, 2 halves, 3 halves, 4 halves, 5 halves. There's 5 halves. Now, if you remember, 2 halves is equivalent to 1, and 4 halves is equivalent to 2. So this is equivalent to 2 and 1 half more. That's what 5 halves is. It's equivalent to the number 2 and 1 half. Now, which one's greater? Is 3/4 greater than 2 and 1 half? Or is 2 and 1 half greater than 3/4? So remember, a fourth is half of a half. So this is 1/4. This is 2/4. Here's 3/4. So here's 3/4. Here's 5 halves. Which one's greater? I'm pretty sure 5 halves is greater than 3/4. So is A greater than B, or is A less than B? A is 5 halves, B is 3/4. That means A is greater than B. Clear all my drawings and submit. All right. I think this will be our last one. This is another Y-intercept question, and then I'll let you kind of try to work your way through this. These questions are a lot tougher than the slope because you have to use the slope to actually find the point. So Y-intercept, again, remember Y-intercept means X is 0. You're basically plugging in X is 0. So in a table, we have to start with the rate of change. So what's the rate of change from 0 to 3? That's +3. And from -8 to -2, that's +6. So my change in Y over my change in X is positive 3 over positive 6, which simplifies, let's see, that's 3 times 3. This is 3 times 2. Take out the 3's. Oh, 3 times 3. This is 3 times 1. Silly Miss Angel. You're left with 1/2. Okay, let's see if that's also right here. Here my change is plus 2. For negative 2 to 2, that's a change of plus 4. So positive 2 over positive 4 is all, let's see, that's 2 times 1 over 2 times 2. Take out the 2's, is also a change of 1/2. Okay. Now remember, it's not asking us about the slope. We have to use the slope to find the y-intercept, to find the value when x is 0. So I'm going to bring this down here. Again, I like to do it horizontally because it's just easier for me to see the changes. You can totally do it vertically if you want. Now, I'm trying to find when x is 0. So I'm looking at this and I'm going, okay, I know what x is when it's negative 2, and I know what x is when it's positive 2. So let's go negative 2. And since my change in x here, this is the hard part, my change in x is positive 2, not positive 1. So every time x increases by 2, I get another y. That will increase by 1. So negative 2, 3 is the point from the table. What's negative 2 plus 2 is 0. And then negative, or 3 plus 1 is 4. And then let's just double check that that's right. If I add 2 again, that brings me to 2. And 4 plus 1 is 5. Yeah, okay, so that's right, because that's how I got from negative 2, 3 to 2, 5. And then look, there's your y-intercept right there. 0, 4, okay? So the y-intercept of function A is 0, 4, or for the sake of this, we're really just worried about the 4. All right, y-intercept for function B, remember it's just when x is 0. So when I plug in 0 for x, this is gone, and I'm left with y equals negative 4. So here, the y-intercept is 0, negative 4, or for the purpose of this question, we're just looking at it as negative 4. So which of these two statements is true? Is the y-intercept of function A greater than the y-intercept of function B? Is 4 greater than negative 4? Or is 4 less than negative 4? 4 is greater than negative 4, so I'm going to clear my drawings here and submit, and here we have it. All right, this will be the last one that we do because this is, we haven't done one like this at all. This is another question where it's asking for a specific value of x and finding a specific value of y, but we haven't done one with a graph. So after this question, we will be done because we have done quite a few examples in this video already. Okay, so it's asking us to find the value of y when x is negative 6. So basically, we know x is negative 6. We need to find y. This is what we know. This is what we don't know. So in a graph, okay, we're looking for the point on the line where x is negative 6. So if I look here, here's where x is negative 6. What's the value of y on the line? So I'm just going to kind of trace this up here until I find the point. Here's the point on the line where x is negative 6. What's the value of y? What's the point between 2 and 4? That would be 3. So this is the point negative 6, comma 3. So in function A, when x is negative 6, y is 3. Let's look at function B. We're going to have to use rate of change here. So what's the rate of change from negative 14 to 6? We might need a number line for that. Negative 14 to 6, zeros in between. Okay, that would be adding 14, then adding 6 more for a grand total of adding 20. Wow, that's a big change. So in function B, our change in y is adding 20. To get from negative 9 to 3, I'm going to do another number line. We'll do it down here. From negative 9 to 3, zeros in between. That's a change of plus 9. Add the 3 more. Altogether, you get a change of plus 12. So that's plus 12. So change in y over change in x. We have 20 over 12, which I'm pretty sure can be simplified. 4 goes into both. 20 is 4 times 5. 12 is 4 times 3. Take out the 4s, and you have 5 over 3. Excuse me. So my change in y is adding 5. My change in x is adding 3. Let's just make sure that that's correct that we believe that with this one. Let's see, from 6 to 16 is plus 10, from 3 to 6 is plus 6. So positive 10 over positive 6, that's 2 times 5, 2 times 3. Take out the 2's, you also have 5 over 3. Okay, so now we have to find the value when x is negative 6. So negative 6 is between negative 9 and 3. So I'm going to create my XY table here. And I'm going to start with the point negative 9, negative 14. And I'm just going to kind of work my way through. Now notice your change in x is adding 3. So to get to the next point in the table, I'm going to add 3 to x. And what am I going to add to y? I'm going to add 5 to y. So what's negative 9 plus 3? I'm moving 3 to the right. That means I'm at negative 6. And negative 14 plus 5, I'm moving 5 to the right. That's negative 9. Let's just keep going to make sure that we end up at our next point, and then we'll come back. So we would add 3 again. Negative 6 plus 3 is negative 3. Negative 9 plus 5 is negative 4. Add another one. Negative 3 plus 3 is 0. Negative 4 plus 5 is 1. And then one more. 0 plus 3 is 3. 1 plus 5 is 6. Look at that. So using our rate of change, we ended up at 3, 6, which is in the table here, okay? But that's not what we wanted. What did we originally want? We wanted the value of y when x is negative 6, and look at that, we have it right here. So in function b, the value of y when x is negative 6 is negative 6 comma negative 9, or in this case, just negative 9. So now we're comparing 3 to negative 9. So the y value of function a, which is 3, is that greater than negative 9 or is it less than negative 9? I'm pretty sure it is greater than negative 9. So that would be our answer here. I'm going to clear all these drawings, hit submit, and there you go. Okay, so this is a little bit tougher of a assignment, just because it doesn't only bring in slope, it also brings in everything that we've learned so far. So you're going to have to calculate Y-intercepts, you're going to have to calculate rate of change in a table, you're going to have to calculate different points for different x's. So you're definitely going to want to have a piece of paper out in front of you. And then if you need help on this one, Mr. Adams and I are available this week to help you and assist you if you need it. This IXL code, again, is going to be due Sunday by midnight. And if you have any questions, please don't hesitate to reach out. Talk to you soon.